The only thing we can be sure of about the future is that it will be absolutely fantastic.
5, 4, 3, 2, 1.
Hello, everybody. My name is Stuart Volkow. Welcome to this edition of Into the Impossible, Innovator Series, from the Arthur C. Clarke Center for Human Imagination at the University of California, San Diego. Virtual reality, augmented reality, extended reality, they've gone through many hype cycles of inflated expectation followed by valleys of disillusionment. Some of the practical applications have turned out to be education, training, job aids. A company founded here at the University of California, San Diego, has successfully applied immersive virtual reality to the burgeoning industries of nanoengineering and molecular engineering. That company we'll learn about today, Nanome.
This is 10 to the negative 9 meters, the scale where all cutting-edge technology is happening. Whether it's precision medicine, chemical engineering, next-generation chips that will go into your smartphone, or the metal alloys that make up the Falcon 9 rocket. Nearly every industry is going towards nanoscale precision. With Nanome, you can import any protein to atomic precision from the worldwide protein databank. You can even start modifying these structures however you want and apply your preferred force field simulation to see how your modifications change the structures. Mutate atom by atom or by amino acids with the mutation menu. Select by reaching in and measure like never before. Even take a selfie with your design. Build with a friend or with random strangers. Nanoscale design has never been this intuitive. Welcome to Nanome.
So I would like to welcome Steve McCloskey. Hello, Steve. How are you?
Hey, Stuart. I'm doing well. Thanks again for having me.
You are welcome. So I met you in 2015. I was actually looking back at some records from then, and you had I first met you in Atkinson Hall, and I noticed you were demonstrating what was, I guess, an early version of what is now Nanome. So I'd like to start out by just asking you to tell us the story of how Nanome came to be.
Yeah, wow, that was super early days. So I mean, you kind of saw at least 80% of the story then, because I remember when we met in 2015. It was spring. It must have been around the that film festival, the art, science, cinema, kind of everything combined. It's at a filmatic festival with Rebecca Webb. So that was really cool that year. They were doing a lot of virtual reality, and I was kind of one of the only people on campus, doing virtual reality, trying to build a product, something cool that wasn't just the academic researchers, which also, they're doing really great stuff. But yeah, I came out of nanoengineering, started working with the visual arts department, Nanoengineering Department, computer science department. Really, we have a vibrant community here at UCSD, so I decided that we should try to get everyone to collaborate and work together in order to accomplish something really awesome. So that was back in late 2014 is when I started getting serious about building the prototypes for interacting with atoms and molecules in virtual reality. And then 2015 is when we really started to grow a team, get our product more developed, started to get different advisors and faculty around UCSD together to help with the project. And it's right when you came in, so that was super early days. And since then we've improved the product drastically, working with a bunch of major pharmaceutical companies. We're in like 250 universities and schools right now. Things have just been growing over the past 4 years since we first met.
Well, you come out of, you were in the nanoengineering major, or you're doing graduate work in nanoengineering. So it's a chicken or the egg question. What came first, the idea to have a company, or did you develop the software? Did you see a niche? Is it kind of a classic startup story where you saw a need, or did you kind of grow into the need?
I was always interested in computer graphics, and I had explored a little bit of computer graphics and molecular modeling as I was going through nanoengineering. But I was always entrepreneur minded a bit. Thought about doing some cryptocurrency related startups. Back when I got into Bitcoin in like 2011, 2012. So kind of kept those ideas in the back of my mind that this might be something that would be cool. But really has came out of a need that I had. As a nano engineer, I didn't think that there were any effective tools that allowed me to do my job as effectively as I wanted to. And so I wanted to create those tools, make sure they existed, use them myself to build better technology, allow other people to also build cool things. And what we found is that there's a huge need in structure-based drug design. If you take a pill, if you take a pharmaceutical medicine, there's an entire journey of how that molecule came to be, why they put it into pill in the way they did, and what effects it has on your body when you're actually putting it into you. And so we help the researchers actually build that molecule from the ground up, before that chemical structure has even been theorized. They start with the scaffolding of the protein, they start targeting it, looking at it in virtual reality, and then designing their molecules based around that information. And virtual reality offers huge insights for that community here. And so we've been working with experts in that field to optimize the tool around their type of nanoengineering. It's still nanoengineering, but it's for drug development and chemical development.
To me, what was unique about this, my own experience of trying it, is the idea that you think with your whole body and mind, and that when you're working with these tools, you can get insight into something because of the extended reality nature. But why don't you just describe what the product is and how it works and what the intent is?
I mean, generally when we interact with our environment, we don't think about it, but every part of our body, all of our senses, they're all getting information about our environment. And for thousands, tens of thousands of years, this has been really helpful for us to be able to build tools and build societies and eventually build great technology like we see today. But all of that is impossible to do at the nanoscale. It's just a really small scale. Humans aren't 1 nanometer tall, and to get down to that level, you need really great virtual reality. So right now with computer-based systems, it's all about the interface between the human and the computer. If you have very low bandwidth going between the human and the computer, it's going to be really clunky and slow. And whenever the computer has new information, it's going to take a while for you to understand and process that information. Once you understand and process it, it's going to be really slow for you to tell the computer to do something different in order to calculate something new. But with virtual reality, you could actually take that interface bottleneck and essentially try to eliminate it piece by piece. First step, getting 2 eyes in there. Extremely important. When you look at a 2D monitor, it doesn't matter if you have both your eyes looking at it or one eye looking at it, it's still going to be a 2D image. But with virtual reality, you put on the headset, you have both your eyes in there. If you close one eye in VR, you will actually lose some of the stereo effect. If you kind of pivot your head around and move side to side, then you could regain that stereo effect. You see rabbits do this because they have eyes on the side of their head. In order to understand 3D, they kind of move their head around in order to see that three-dimensional image of the world, because they have a very small window of stereo sight in their front view with both of their eyes being able to see that. So that's step number one. Obviously next you get your hands in there and you start getting better input to the machine. You're able to move things around, change things, modify them in real time. And that's super important to be able to tell the machine what you want it to do. We just see it as a big input-output situation where you want to reduce that barrier as much as possible, increase the bandwidth, and really get the human and the machine working together very fluidly.
The other aspect of this that makes it unique as opposed to other ways of working is collaboration, right? You can be in there with your colleagues working on the same molecular models and manipulating them together, right? So tell us a little bit about that.
Yeah, definitely. So, historically what we see is a 2D molecular viewer. They're going to be very siloed where it's just one person working on it. if they want to collaborate, then you have all the beautiful graphics and the protein structure on the 2D screen that then gets sent over a video share, Skype, Zoom, you name it, just like a typical video stream share. So they'll take that and stream it to a colleague that is not next to them, or if there's a colleague next to them, they're still looking at the same computer. But with virtual reality and with our application, everything is networked. And so you could actually be in this virtual world looking at the protein structures together, you zoom in, make it ginormous, make it really tiny. All of this is shared. And so you're able to communicate the structural information, communicate the structural insights that each specific researcher that focuses on that particular part of the field would have. For instance, a structural biologist could pull up a protein with a few chemists, talk about the significance of different parts of the protein, and then the chemist could actually actively develop new molecules in that collaborative session. And that's what we're seeing is this collaborative structure-based drug design approach in virtual reality.
Nanome, the company, has grown by leaps and bounds. You are part of a program called the Qualcomm Institute Innovation Space, and you've recently moved out of there, and you've achieved some spectacular results in your journey just in a short amount of time. I mean, really, it's been about 2 years, I think, since you've really been operating. So how does that feel, and what were some of the challenges that you faced getting to the point where now you're off and running, right? You're out of the incubator into the real world.
Yeah, it feels really good. We have our own office space now. It's actually in a really cool part of San Diego. It's in this very iconic pyramid building that everybody seems to know. But yeah, it's great. We got our whole team over there. Very collaborative. Sort of open office environment. That's really great. The big challenge right now is just getting our software out there to more people. Yeah, we're working with a lot of the big names in the top pharmaceutical. We're working with top pharmaceutical companies right now. Working with some smaller biotechs, a ton of universities. So right now, why not work with all of the top 30 pharmaceutical companies in the world? All of them could benefit from our tools. All of them are interested. So right now, just closing that gap between meeting the scientists and the researchers at these conferences, and getting their teams onboarded onto the virtual reality ecosystem and getting them set up, deployed, and then really using it to make the next generation of medicine.
So what are some of the challenges? Do people resist the idea? Your product currently works on Oculus. I think it works on Oculus and Vive. Is that correct?
Yep. Oculus, Vive, the new Valve Index works pretty well as well. Some of the Windows mixed reality headsets work okay through the Steam VR. But yeah, Oculus and Vive are the main VR hardware solutions.
So were there challenges in getting people to accept wearing these headgear to work with this product, to take it seriously?
Some of them have just been waiting for this moment. They tried all the headgear from, the 80s, the 90s, the 2000s. You go into their office and they have, 5 pairs of stereo glasses at different points in technology development. So they've been waiting for this, 3D VR moment to happen. They've kind of always imagined it in their head for the past 30 years. So a pretty good amount of people are actually like that we talk to. Yeah, some of them are new, and they're kind of used to the way that they started learning these two-dimensional tools. But they're actually pretty willing to adopt new tools. They see a lot of the frustration that happens with the mouse and keyboard-based input, needing to rotate use their mouse to rotate the structure in order to get a stereo view, or at least understand how the three-dimensional view would be when it's projected on a 2D screen. A lot of them are experiencing the pains and limitations of 2D, and they're very ready to adopt. There are a few laggards that are just kind of anti-VR, but I'd say that's less than 1% of the people that we meet.
You really pushed the envelope on UX on this product, and I'm really impressed with some of the elements of your UX. You've got this sort of Dick Tracy wristwatch toolkit that is on, you can flip your hand over and you can come up with contextual menus in various very clever ways that require using the hand controllers uniquely, but it kind of is taking cues out of gaming and entertainment products. How did you come up with this? I mean, was this trial and error? Did you find some UX superstars? How did that work?
So yeah, I grew up in North Hollywood, so I was always around that sci-fi like entertainment type of Minority Report and Go Go Gadget, all these sorts of things that have probably propagated somewhat into our UX design. But I'd actually credit a lot of that to just UCSD in general. The computer science professor we work with out of Cal IT2 Qualcomm Institute, Jürgen Schultz, he's been working on VR interfaces for like 25 years in academic research. So he was able to share, kind of like best practices, what's been tried before, what doesn't work, what is still to be tried that might work. And we really need to take that information and roll with it and just come up with new creative ideas. And that's where we all get together. Me and my chief experience officer, Edgardo, he has a background in cognitive science, human-computer interaction. And so, we talk about these. It's kind of like multiple stages. The first stage is like brainstorming. It's like, oh, what if the hand kind of just go gadget like turned into different tools like as the user was using them and cycling through different ways. So this one would be the bond rotation tool, and then this one would be the atom manipulator and like chemical builder tool. This one could be selection. And so we kind of like bounce these ideas around. So that's like first stage. Second stage, we actually get into VR and try these things out and try to like prototype it as best as possible and get a good feeling for it. And then we actually implement it in a piece of the software, try out that, and then we put it into full production. So there's kind of like multiple stages, but a lot of trial and error. But some things we come up with just kind of work. It's probably not the ideal solution that if we had unlimited time and unlimited resources that we would have come up with. But it works, and it works pretty well, and it's very compelling. And so when we have a feature like that and an interaction like that, we'll run with it, get some customer feedback, see if we need to modify it a little bit more and make it better. But we're always looking to make this product as intuitive as possible. We see 5-year-olds pick it up, and they don't understand the chemistry, they don't understand the insights of structural biology. But they could pick up a protein and they could make it bigger, and they could draw a chemical benzene ring. Like we just try to make it extremely intuitive so that every kids could pick it up pretty well.
Make no mistake, though, this is a serious tool that high-level scientists and nano engineers use for molecule creation as well as drug discovery. So I want to make sure people realize that it's not a toy, right? But
if you make it so that the 5-year-old could pick it up and kind of get a hand for it, then when you go in and you meet with the vice president of medicinal chemistry at a multi-billion-dollar pharmaceutical company, and you tell them to put on the headset, they're able to pick it up and get started pretty quickly as well.
That's remarkable. You also have explored integration of blockchain technology into this, and you've formed another unit of your company to integrate this technology into not just drug discovery and biotech, but almost any kind of technological scientific innovation. Maybe you can get into that a little bit.
Okay. Blockchain's been really great for things like keeping track of money, who's sending which money to which people. We've seen that through Bitcoin. One of the new iterations of a blockchain-based platform is called Aetherium, and that allows you to write smart contracts, which are kind of like contracts in real life where you sign the agreement, somebody else signs the agreement, and then you both need to abide by the terms that are written down in that contract. Except for when you run it on Aetherium, there's no trust that you need between the parties. Once things are deployed and the contract is set up on the Aetherium virtual machine, which is kind of like a global supercomputer, once it's set up there, it will absolutely do what it says it will do. And so you write this smart contract code, deploy it, and then people could use it freely as an intermediary between different transactions that they have. And so what we do is we say that if you use our smart contracts, we allow you to hash new intellectual property onto the blockchain to give you an immutable public timestamp to show that you were the original creator of that new piece of intellectual property. And that could be anything from a new chemical design to a new 3D object for a video game. It just really could be any digital piece of information. You generate a hash, which is like a cryptographic fingerprint of that file that only you could create if you had the file. And that allows you to give a timestamp without actually disclosing what you have made. You could choose to also disclose it, because once you have the timestamp, it's a very good record to show that you were the first one that made that. You could also do this alongside a provisional patent filing as well. So we're linking that up with different users so we could help them file within the government regulatory system. But we think that the future model is generally going to go to first the hash over first invent, so that whoever has the first publicly recorded hash on the blockchain is the original owner. So I think that could potentially be a global patent system. And we're very interested in that because it allows us to do new things with our technology. So if you think about pharmaceutical drug development, it takes like 12 years, $2 billion to get a drug from initial idea all the way to market. And any way that you could think of to help reduce that number is going to help save lives, is going to improve the quality of people's lives that are living with different diseases. And the way that we think we could do it is by crowdsourcing chemical development. We built this very intuitive virtual reality software that allows you to analyze protein structures, design chemicals. The next step is to really host crowdsourced tournaments to say that who wants to target this malaria protein. If we target it, it might have some effect. Let's all create a bunch of small molecules that will interact with that malaria protein. The winners could get rewarded in some way. Everybody that comes up with a new design is getting the right attribution for their work. There's a lot of stories throughout science where just the right people that made the right insights never really got credited with what they were doing. For instance, Rosalind Franklin with DNA. Francis and Crick really ended up getting most of the credit for the work, but she was right there in the trenches, doing a lot of the work too. And so we think that blockchain is this universal way to get people the right credit for the work that they're doing, and allow that to form a larger structure of crowdsourcing and getting people to work together to solve some of the world's biggest issues.
So that's very ambitious. How does that fit into your plans? Where are you going with this? I know the company is growing very fast, and there's a lot of challenges with growth. Give us a little teaser on where you're going.
Yeah, so right now it's fully live. It's deployed on the mainnet, which is the main Aetherium network. So it's fully usable, live, functional today. We think that the next big step is just adoption. All of these universities we're working with, all of the students that we're working with, maybe there's some smart PhD grad students that would like to earn some side income by developing some new chemical structures. Maybe there's some gamers that are trying to see if they could help with science in any way they can by solving this little three-dimensional puzzles. So that's kind of one aspect of the business going on. I think that's going to have some slow growth and adoption, sort of as people pick it up and think it's cool, they'll start using it. There's a little bit that we could do on our side, basically link up researchers that want to crowdsource some of their work, get them onto the platform, link up our virtual reality users with the blockchain platform through our plugin API. That basically allows you to connect any piece of computational software with our virtual reality application. For instance, it's really popular for molecular dynamics, where you could simulate how atoms would move over time, be it a small chemical structure or large protein. Chemical docking, so if you have a chemical that you would like to dock and score within a protein, that's a plugin that we have as well. And so another plugin will essentially just be hash your work on chain, kind of like timestamp this. And then you just click a button, first the hash, you click that. That'll use the Matryx platform to then hash your work onto the blockchain, kind of give you the information, and then you have an immutable timestamped record to show that you created it at that point in time.
Now, you've got an academic version of Nanome and Matryx that people can use, and then you can get up to a pro level and, of course, enterprise level. But you're covering the base for the individual, too. So if people want to use Nanome, how do they go about it?
Yeah, so you can go to Nanome.ai, and you could find our application there and download it. It's also available on the Oculus Store. If you just do a quick search for Nanome, or if you search on Steam or Viveport as well. We just try to make it very easy, integrated within all the virtual reality ecosystems. So yeah, just go on there, download it. You can make an account for free. start using the free version, kind of get a feel for it. That's all going to be public, so you're going to have other people around the world joining the rooms with you. And yeah, I've met people from everywhere. I've gone into free public rooms. I've met people from Australia, from Mexico, people from Europe. Somebody from China the other day. I guess we get past the firewall there. A lot of people from Japan. So it was really cool to see that once you put something on the internet and you make it downloadable and it's on these different app store ecosystems, you really get this global community of people that are interested. You have 7.5 billion people around the world. Chances are there's going to be many people interested in this, virtual reality, chemistry, like crowdsourcing, drug development aspect. And we want to help get those people all together into our app.
I wanted to ask you about the VR, XR, AR world, what you think of it in general and where you think it's going. Are we going towards a Ready Player One kind of a thing where we're going to be all going to school in some Matryx-like world? And I know you haven't quite gotten to AR yet, although I've seen some signs of that around your office. Are you going that direction? And how long do you think it's going to be? I mean, of course, I'm thinking about the Oculus Quest, which is now a consumer grade or prosumer grade. Pretty good, I mean, as far as I'm concerned, the untethered experience. But what's your view of that, of the state of the industry?
Yeah, I mean, I love the Quest. It's been probably the best headset that I've been able to buy and use so far in the VR scene. There's people kind of on, if you look at Ready Player One, at least the movie, is people like on the sidewalk, kind of in VR in their own world, just doing their own thing. We're starting to see that with the Quest. There's a famous picture going around Reddit with father and his son next to their Tesla in virtual reality in the Oculus Quest. Playing some games as they're waiting for their Tesla to supercharge. So that is today. That is 2019 virtual reality landscape. That's probably going to continue. You see people on their phones, day-to-day lives. Why not be in your own world instead of just looking at a 2D screen that's in your hands? So I think that's going to just become more public gradually. We're going to see that over the next decade or so. Augmented reality, I could definitely see that getting miniaturized and becoming more ubiquitous with just glasses that people wear, sunglasses, prescription glasses. Just make it smaller, lighter, cheaper, better resolution, more apps out there. We've explored a little bit of AR. The technology is still a bit clunky. Pretty good for like aircraft maintenance and things where you need an overlay of augmented things on top of the real world. But for our uses, it's all computational nanosciences, computational chemistry. So there's no real world analog necessarily. You don't need to see the beaker in real time or see the chemicals in real time. It's really once you come up with the blueprint and the design for your chemical, then you could synthesize it either by manually mixing chemicals or with the robots that will automatically do that for you. So yeah, with us, we're really excited for just the virtual reality potential out there right now. Augmented reality will probably catch up, and the both will probably be maybe equivalent in 10 years. Who knows where that's going to go. But yeah, I think that there's a pretty long way for the technology to go. We could manufacture screens with the resolution of a human eye. We could do all sorts of things with eye tracking to help be able to process the high resolution bits of that screen at a certain time. So even if Moore's law slows down a fair bit and the GPUs don't get too much better, there's still a fair bit that we could do. But of course, if the GPUs keep getting better, there's a ton that we could do, and that world is going to be absolutely crazy.
I want to thank you so much for that. The insights you have on the industry in general are so relevant because you're doing what has been theoretical for so long, and I think you're one of the few companies out there that has a working industrial strength, enterprise grade VR product that has traction, and the future is looking bright.
Yeah, we're always growing. You're always looking for more adopters. But yeah, it's getting to the point where it's not just early adopters. This is becoming a very ubiquitous tool in the pharmaceutical industry, and so I think that's going to continue to grow, and we're going to see other fields in material science and chemical development also emerge as well.
Thanks so much for your time.
Cool. Yeah. Thank you, Stuart.
The only thing we can be sure of about the future is that it will be absolutely fantastic.
5, 4, 3, 2, 1.